Hey, and that worked without a problem this time. Cool. So we're recording. We've got everyone here. I've just sent out the friendly reminder for anybody who didn't get the link earlier this morning, and I think we're good to go. So are you ready to present? Well, actually, here, let me say first, I don't really have many updates for the group, except since the last time we've met, I don't think we announced that we sort of started a new iSWAT working group to be extending the effort on building a PyHC environment. We're pulling in some other people, and we're going to try to make it more of a developing a few different Python environments to be used for heliophysics in general. And it should be an exciting working group. So look forward to more information about that. But now that's all I have.
Let me turn on my camera so you can see me. Should I start sharing, start presenting?
Yeah, go for it, Andrew.
Sure.
You want to give us a little bit of an introduction about who you are and what you're presenting here? I know you're going to be talking about the work you've been doing with mission packages and the CDF writer, but please feel free to introduce yourself and then take the floor.
Let me just rearrange Zoom.
Yep.
All right. So my name is Andrew Roberts. I am a senior data scientist at GD Mission Systems, and we're partnering with the Hermes mission and the Space Weather SOC to help build some mission pipelines and data analysis tools. So Damien and I are working together on the Hermes mission. Damien has focused more so on some of the AWS pipeline processing and AWS infrastructure. I've focused more on the Python code to enable data analysis, calibration, loading and writing CDF data products.
And quick question before you go on. I'm remembering correctly that you presented this at one of our spring meetings, right? Do you remember how long ago that was? Or maybe not you personally, but someone from your team.
It was probably not me at the time. It might have been Damien or Stephen Christ. I don't see Stephen online right now.
I'm wanting to say that was spring 2022 was the last time we heard from this package. I was just going to give that for context, but that's okay.
Okay.
Continue.
Yeah, so we can get into it. So the presentation that I have is a set of slides that I had presented or put together for presentation at Dash about a month ago, and we had them as a poster exhibit there. So I'll click through these in some kind of order, but as you have questions or interest, I'm happy to jump around. So the Space Weather SOC is a multi-mission SOC organization that will provide cloud pipelines, processing, analysis, and backup tools, monitoring through Grafana, and instrument performance and metrics tracking, again, all through the Grafana interface. So you can see what stage data products are in within the processing pipelines. And Damien's built some cool dashboards as well for monitoring egress costs within the AWS SOC architecture. Really cool tools that he's developed. And Hermes is a instrument suite that's going to go on the Lunar Gateway. That has 4 instruments on it to measure space weather variability around the moon as part of the Lunar Gateway. And it is utilizing some of the space weather SOC architecture and designs. So the space weather SOC uses, and Hermes uses, an infrastructure as code deployment into AWS. And this is something that Damien's going to talk about in a little bit, so I won't dive too deep into it. We have a couple really great tools, S3 Watcher and a file system watcher, that will monitor incoming data products and pass them into sorting lambdas and processing lambdas. And those data products are tracked by a CDF tracker tool that monitors, what data product level, what level of analysis our files are coming in at, and what levels we're processing them to. And we've also integrated a Slack notification service for our mission Slack channel, where we can see incoming data files and status from the processing pipelines. And Damien can probably go into more detail in this at length in his presentation. I'm going to focus on this box in here, which is our processing lambda, and some of the code that we've developed to aid in that. So within just the processing pipeline, we have a couple steps that'll parse file names, and Hermes has 4 unique instruments. And so we've set up the pipeline so that the instrument-specific processing code is handled in an elegant way. We import an instrument processing package, which is a separate Python package based on the file name and the instrument that's pulled out of the file name. And then we call dynamically that instrument's own processing code for the data level that the incoming file is at and the level that we're processing it to. And then it's uploaded to an instrument specific bucket. And Damien, again, has really great dashboards that'll do tracking of that, notification services, and calculate egress costs from those instrument buckets. And so within each of the instrument processing calls, we'll dive deeper into that. So the Space Weather Stock has a generic instrument package template, which can contain processing code for any instrument. And so Hermes has forked that package to a Hermes specific instrument package template. And there are 4 instantiations of that template, and it's using the cookie cutter package that will instantiate all of the template, or instantiate all of the instrument packages for our EEA instruments, the Nemesis instrument, the Merit, and SpanEye. And each of those packages contain what is this abstracted function process file. It's very generic, takes in a path to a data product, and it will give out a list of paths to processed artifacts, whether they're higher level data files or plots or any other higher level data product you might want to generate. And each of these 4 packages for our instruments leverage common functionality in a Hermes core package, and we'll dive deeper into that in a minute. Any questions so far? Damien, do you think I've missed anything?
Nope, I think you're right on.
Okay. So within our Hermes core package, we've created a generic data container that can load and write CDF files to be used for the different instruments that we have. And so EEA, our electrostatic analyzer, is associated with spectral time series measurement data. Nemesis, associated with scalar time series data. Miniaturized proton telescope Merit, takes use of spectral time series data, and SpanEye is also spectral time series data. And so with a variety of needing to handle in a Python format, a mix of scalar data and spectral data, in addition to support data that might be non-time varying scalar items or non-time varying tensor items, we needed to come up with a set of data structures that could handle each of these unique kinds of data. And we implemented those in this Hermes data container. And so it has IO capabilities to read and write CDF data files so that CDFs that have spectral time series data are loaded into a data structure that is optimized for handling high dimensional time series data. Scalar time series variables are loaded into a data structure that is optimized for scalar time series data, and non-record varying data is loaded into a separate data structure, also optimized for support data. And some of the unique pieces that we've added to our data container are attribute derivations. So for common global and variable CDF attributes that are required for ISTP compliance, we've written some code that will actually derive many of the required global metadata attributes and variable metadata attributes associated in the CDF file. So it's a lot easier when you're building out a CDF file to add in the data and use the derivations to derive almost all of the metadata attributes that are required. And so you don't have to template some of those those metadata attributes out in skeleton files. And we've added tools for analysis, plotting, and another unique piece that we've added is validation libraries. We've extended some of the SpacePy validation, as well as integrated validation with the derived attributes. We've created I like to think of it as kind of a manifest file or a configuration file, which will outline what attributes are required, what global metadata attributes must be filled in, valid values that those attributes can take, data types that those attributes can take, and then we can validate CDF data products against that schema and report errors that certain metadata attributes, global or variable, don't take the right data type. Those metadata attributes don't appear when they're required, or don't meet one of the valid values. So, for example, one of the metadata attributes might be display type for a variable, and that display type can either take a value of time series for scalar time series data, or spectrogram for higher dimensional spectra time series. And we can validate the display type metadata attribute against its schema allowed values, which is really neat. Any questions on this? I think there's no. So within our data container, we've provided data structures to enable analysis of many of our data types. So for scalar time series, we have there's a Hermes data.time series member, which is an AstroPy time series and has convenience for subsampling and slicing scalar data based on those time units. And all of the columns of our time series are grounded in real world units using AstroPy quantities, which is very handy. For higher dimensional data, spectral time series, we have a dot spectra member, which is an ND cube collection, an ND collection object that has WCS objects within it for handling coordinate transformations of the higher dimensional data. And you can slice along multiple axes simultaneously using the ND cube API underneath. And then we have a support member, which is a dict of ND data objects, AstroPy ND data objects, which are non-time varying support and metadata variables. And they can either be scalar ND data objects or vector or tensor ND data objects. And so this is a different kind of use case architecture diagram of Hermes core. And this is the Hermes data. Maybe it's a little bit bigger. This is the Hermes data container, and we have a Hermes data schema. This is the schema that I had talked about earlier. We have a global attribute schema, which contains all of the information on what global metadata attributes are required and the values that they can take and the data types they can take. The variable attribute schema, which is for variable metadata attributes again. And we've created some template functions that allow you to ask for a template and it'll hand you back an empty dictionary where all of the keys are matched to the required metadata attributes and the values of the dictionary are empty. And so it's a lot easier just to ask for a template and you get all of the pieces that you need to fill out. You can fill out those pieces and you can use those in the data container to generate your data products. And so there are a couple of use cases that we have to create a new CDF data product. Again, I mentioned those attribute templates, and these delegate to the schema class to augment, add, modify data. We have functions that'll add individual measurements, whether they are spectral, scalar, or non-record varying. We have a function to append data. So if you have multiple data products that you want to combine along a time dimension, you can pass those in and it will append along the time scale multiple data products together. We have plotting just to generate kind of quick look style plots. And you can also load an existing CDF file. This uses the SpacePy PyCDF library underneath. And this will populate each of the class members with the CDF variables that kind of fit in those members. So scalar variables within the CDF will be populated within time series. Spectral variables within the CDF will be in the ND collection, and non-time varying variables will be loaded into the support member. And global metadata is accessed just through the .meta member. And as I mentioned, we have also created a validation class that can take in a CDF schema, or it just takes in a file, but it contains a CDF data schema, and it will validate your CDF file and give you back a list of validation errors that it might have against the schema and against SpacePy's PyCDF validation. And yeah, so the latest development that we've added to our data container is this Spectra member, which is an ND collection, a group of ND cubes. And this gives advantage of doing coordinate transformations within our data container to physical coordinates and during processing and calibration. And it also enables during analysis to do slicing based on physical values rather than index-based values. So rather than having to slice based on a set of indices, index, 0 to 10 or 5 to 6, I can say I'm interested in the 100 EV to 1000 EV range of values in this spectra, or whatever range you might want to be, but you can specify real world unit values to slice based on rather than just index values. This is a really powerful class that we are using. All credit to the developers. And so some generic impacts of the Hermes data container and what we've been doing in Hermes core. Data format, CDF data is complicated and it can vary greatly between missions. And so Hermes has developed these set of tools to make building CDF files easier through automated metadata attribute derivations, alleviates the need to have skeleton files that have templated pieces stamped out. Our schema for a CDF file encoded as YAML enables faster data validation and this metadata derivation, and our well-defined and tailored data structures for each of the different kinds of measurement data that you would want to access enables easier analysis. And all of these tools are currently Hermes specific, but we have been looking at making them more abstract and making them more available through some of the other larger packages that are out there. And I want to, this is a thank you slide. Thank you to the organizations that have made this work possible for us. You guys at PyHC, AstroPy, that enable a couple of our data structures. SpacePy enables our CDF interfaces and ISTP validation, and SunPy, which we've gotten some code reuse and design inspiration from. And I think that's it. Any questions, comments, concerns?
Very nice. Thank you, Andrew. I was going to ask if you could remind me, when you built these packages, were they the first that were built for the Hermes mission, or did they replace something that, like a pre-existing pipeline?
They're built off of probably what you saw in 2022. I don't know if Damien, you've been around for longer than I have been around. I don't know if you remember that presentation. I don't think we're replacing existing functionality. I think all of this is new, but Damien might know better than I do, or Amy, if Amy is on.
So I'm pretty sure the packages and like everything was all kind of like done beforehand. It was sort of like set up as like boilerplate for things to be kind of filled in, and then it kind of got more like Steve set everything up with sort of like how he envisioned each package working, and then from there we worked on it. So this is for like a future mission. I think it's going to be. I'm pretty sure. Correct me if I'm wrong. I know Steve Chrysler or Amy's on. I think in it's going to be launched in like 2025. So all this is going to be kind of like was developed like from the beginning in this sort of setup.
Mhm. I wanted to add also, Damien and Andrew, that this isn't like a lift and shift operation. Like Hermes didn't have a ground system that is now getting moved to the cloud. This is building for cloud native. That's
That's
all.
good stuff. And I love seeing all um the use of other PyHC packages and everything and how it brought the vision together. That's exactly the kind of community work we like to see here at PyHC.
I really liked this presentation, Andrew, and I'm thinking I want you to give it to my GDC instrument teams as well, since we'd probably like to leverage the same or similar architecture, and we got to start selling them on it. I see some of our people from GDC are here, Greg Lucas and a few others. This is probably something we're going to bring to that mission as well and extend it to other heliophysics missions as possible.
Sure, I'd be happy to talk to more people.
I want to be a little bit wary of time that we're about the halfway mark of the telecon, but we've still got a minute for more questions if people have any. Going once. Well, if not, then we might let Damien take the floor.
Yeah, sure. I want to extend a special thank you. I apologize if I pronounce your name wrong. Nabil, you helped me submit my first PR to ND Cube. So I'm very thankful for your help there.
Share my screen.
In the chat, he replies, "No problem."
Excellent.
Awesome. Can you guys see my screen?
Yep, crystal clear.
Perfect. So I actually gave a talk at Dash. So I don't know if anyone was at the kind of open source session on the third day in the beginning, where I kind of like went through and kind of related to how like what some of the work we're doing at Space Weather Science Operations Center and how it kind of relates to the open science push and initiative. But today I'm going to kind of like focus more on like what we do with our infrastructure, and as Andrew mentioned, how we're sort of quote unquote like cloud native, and how we set everything up with infrastructure as code, as well as continuous like integration and deployment, and like hopefully it can kind of like give some ideas for others, or I don't know, it like spark some sort of discussion on like how others have their CI/CD set up, and I don't know, yeah, let's kind of go from there. So I kind of just want to start off again because I'll be using the word mock and sock a couple times. I just want to make sure we're all on the same page on what a ground system is, and how like a mission operations center or mock is just a facility that is responsible for like the daily management and control of kind of spacecraft, overseeing its health status and commanding functions to achieve some sort of mission objective. While the Science Operations Center kind of gets the data from the mock or like Mission Operations Center and process that data into higher data levels, as well as just provide operational support and kind of aids in coordinating any sort of instruments or observation systems. And there's just like a small like little graph on how that works, or a little diagram. And yeah, so, and you've probably already seen this sort of like what our pipeline kind of looks like from Andrew's presentation, but just kind of a brief like go through of the flow of how the data gets to the SOC. So it kind of starts again from the mock, binary files come from there, hits our on-premises server, and then we have this sort of containerized tool called FS Watcher that I've developed, which is kind of sort of like event-based It notices when it kind of watches the directory, notices when there's any new like files, and then pushes it to our incoming S3 bucket in the cloud. I kind of went with like developing this like event-based approach, because originally we had cron jobs, and when we were like testing out our pipeline, it was a bit we had it just set up with like a simple AWS sync with cron, like a cron job, and I don't know, we had it like syncing every like 15 minutes, but then we had to reduce that, and I don't know, since everything else is event based, like how we like go upon processing in the cloud, I kind of wanted to have a similar thing happen, like at least getting the files on premises to the cloud, as well as getting stuff from the cloud on premises, which I'll talk a little bit later about S3 Watcher. But yeah, so when the files hit our incoming bucket in our like AWS account, then we have this sort of like sorting Lambda function kind of pick up on those bucket events and sort each kind of binary file into their appropriate like instrument bucket kind of level 0 folder. And then from there, the AWS like processing Lambda that I set up with kind of the Hermes core and Hermes instrument packages that Andrew talked about earlier today. It goes then processes like those binary files up to like higher like data levels. So first it kicks off level 0 to level 1, and then from there level 1 to quick look, and then eventually, hopefully, we're looking to support like higher data levels in the future. But currently, like we only have it up to quick look at the moment. And that then triggers more like bucket events to kind of hit an SQSQ, which the S3 Watcher that we have on premises is sort of like polling and then like noticing when there's a new file, and then pulls those new files back on premises to just kind of keep that sort of like event-based flow from like beginning to end. And then from there, that all those get synced to like the like SPDF, as well as some instrument teams who might want their copies of their files like directly. So that's just kind of like a sort of like overview of like the flow of the pipeline. Any questions on that piece? Cool. So yeah, now kind of going into more of like how we sort of design the pipeline. So fun fact, I'm sure, I think that this was a pretty popular kind of IAC sort of kind of tool, which is AWS's Cloud Development Kit, or CDK. So we originally went with that approach to kind of code everything, all of our infrastructure. We had different kind of stacks for each of for deploying our sorting Lambda function, our processing Lambda function, as well as just like our normal like infrastructure, such as like S3 buckets, like not Lambda functions, because those are deployed with the other tools, but like the RDS databases that we use for like CDF tracker, and other just kind of MISC things that we need, like resources in AWS, like IAM roles, etc. But and eventually I got kind of frustrated with like the development process with it. I thought it was a bit slow, because it does use CDK does use CloudFormation in like the backend. That's how it works. When you do like a CDK sync, it just creates a CloudFormation template based off all the Python code that you wrote for it, and then it deploys that stack. And CloudFormation fails very, like when it fails, you have to kind of go through like see why it fails, and it takes so long to just kind of like backtrack. And I don't know, it was such a pain to kind of develop all the infrastructure with it, and I kind of jumped on the Terraform train recently with some of the work I've been doing with CCMC, and I kind of did this big write up on like why we should refactor and do Terraform, and I was able to kind of refactor that in the span of a week, because thankfully when you have infrastructure as code, it's not that difficult to kind of transition to a different tool, even if they're like kind of different in nature. For example, CloudFormation or CDK is imperative. So it kind of does everything like as a sort of recipe. It goes step 1, 2, 3, while Terraform is more of a is declarative. So it's always trying to get to a certain state. So I think that kind of method of keeping infrastructure as code is a bit cleaner, as well as just like the development like process is way easier. And then you're also, there's no vendor lock-in as well, because this sort of pipeline could work on Azure or Google Cloud or whatever other cloud like services, because each one of them have kind of similar services to AWS. But right now we're currently set up with just AWS. So that's kind of like our, like why we, like what the refactor. If anyone's interested, I can get you like the write-up I did. But yeah, so, and then all of our, we have a bunch of variables that like help us abstract the pipeline. So hopefully this could like transition easier for like easily to other missions in the future. And all of it's available on our GitHub repository. For any questions on like our use of Terraform? Cool. So now kind of transitioning to our like CI/CD and like how we sort of have that set up at the SWSOC. So we all our repos, we have a GitHub orgs page for Hermes. So all of our kind of public repos are hosted in GitHub. We have GitHub Actions set up for like testing, building our documentation with like Sphinx, as well as linting on any like new pull requests to the main branch of the repository. For like Python repos, we have just like the PyTest sort of like suite with like plugins such as like AstroPy support, and other ones. We have like docs again, Sphinx, and linting we do Black and Flake8. And then for the IAC repo, so again, we're still, since it's a pretty recent refactor from CDK, we're still refactoring it to like for like the docs and like the testing from like CDK, since we still have the CDK like code in our repo, so you can actually go back and see how we have that set up. But in our Terraform folder, we still have like, I'm still working through actually like refactoring our like automated like CI/CD for our infrastructure as code repo. And yeah, we also have scheduled runs every day to kind of verify that there's like no issues with any of the pipelines that we have set up, and just kind of ensure it's fresh. And yeah, and we also utilize AWS code build for deployments. So since we're on a sort of a GitHub like orgs like kind of free use repo, we have a certain amount of like runner minutes that we can utilize. So since we have an AWS account, we kind of just keep those minutes for all the PRs and like all the like nice like quick stuff that we can do with GitHub's actions, and then kind of like push some of the more like costly and like longer running pipelines to our AWS account with AWS code build. And that also just lets us easily kind of deploy stuff with IAM roles assigned to the code build process. And yeah, and for testing, we test across like all of our packages. We test across like different operating systems and modern like Python versions, just to kind of ensure it works in like different environments. And there's like certain like tweaks that you have to do of like more specifically, like the more recent example was when we were trying to get test across like for SpacePy, because we added that new dependency to Hermes core. I had to make sure it worked on all different operating systems, and for that you have to include the CDF binaries. So I had to ensure that like the each like pipeline, each testing pipeline had access to the appropriate CDF binaries. Yes, Jonathan Neal.
Yeah, I just wanted to ask, we're planning on starting to include the CDF binaries in our binary wheels. Will that help you out?
Oh, that'd be awesome. That would be awesome. Yeah.
Okay, cool. It might not happen next release because the Linux
No
wheels are
worries.
definitely not next release, but it's definitely something that's on my agenda.
Heck yeah, that'd be awesome. Yeah.
Cool.
Yeah, and then we like also maintain a kind of development container. I don't know if anyone's familiar with like the VS Code dev containers, where you can kind of like set up like certain containers, and then people can when they pull their repo, it like sets up the dev container to like all your specifications. And since we kind of maintain a sort of base image container with all the needed like CDF binaries, Python packages, everything set up how like we utilize it within the pipeline. For example, like the processing Lambda function is a container-based Lambda function, and that's actually the base image for the container-based Lambda function. So it's basically using the same exact container that we run like in our like processing pipeline. It'll be the same container that you're developing on, just to kind of keep that consistency and ensure that things like work like throughout. And yeah, and this is just kind of how we like have our flow of our CI/CD set up with all our like different repositories. So you can kind of see like the Python packages and any changes to those ones kick off like the Lambda functions to kind of rebuild. And then from there, like right now, our process Lambda functions a container-based one, so that's why it gets like pushed to like ECR, which is Amazon's container registry. And our sorting Lambda function is currently a zip-based Lambda, so that's why it gets pushed to S3. But we're actually looking to refactor that into a container-based one as well, just to kind of keep things consistent and use that same exact base image that I mentioned before. And then from there, like the pipeline architecture kind of gets any sort of changes to those, like actually updates the Lambda functions from it by pulling the ECR images or like the zip file from the S3 bucket. And yeah, and here are just some other tools. Like as Andrew mentioned, we have like the mission core and instrument packages. I also like was working on a CDF tracker tool to just kind of help keep track of all of our sort of like kind of science products throughout the pipeline. And it kind of ties currently like each like product like to like the original like binary file. And like we hope to expand that like tool in the future to actually like have some of like the CDF data as well. But that's probably going to be a bit in the future. And yeah, we also have the FS Watcher and S3 Watcher that I kind of mentioned before. And there's just like another QR code to Andrew's like presentation and poster if anyone's interested. And yeah, that's just all I have to share today. And I hope it was helpful. Or if anyone has any questions, please let me know. Thank you.
Thank you very much for that, Damien.
Thank you.
Well, do we have anything in the chat No, none in the chat. Well, if nobody has any questions, we might get 10 minutes of our day back. Oh, here I can read a question from the chat. How hard was transitioning from CDK to Terraform?
So like not hard at all, honestly. Because I the beauty with like Terraform is like you have all the sort of all the documentation for the AWS like modules is like really nice. And with CDK, I did notice there was like some resources that didn't have any like level 2 constructs, which has all like the nice bits. So you have to kind of like basically like put CloudFormation sort of code in it in like the Python just to kind of like make it sort of work. And it's not the best readable. So I kind of just started off with like going kind of resource by resource and just combining and abstracting some of the resources that like in CDK, for example, you can like just do like a loop in whatever language that you choose to do CDK on. And like Terraform, there are like equivalent like loop sort of like programmatic structures that you can do. So I just like recommend like going resource by resource and like doing it piece by piece. And then each time you do it, you can actually import existing infrastructure that already exists in AWS. So if you have any infrastructure that you have like deployed with CloudFormation, you can actually import that into your Terraform state so that you can kind of verify that you're doing the correct thing like along the way. Or if you already have all this infrastructure, like with your CloudFormation thing set up, I recommend using this tool called Terraformer, which is a tool developed by Google, which it basically goes through like your like AWS account and like creates like Terraform files of all the infrastructure. Because you can easily do that. Like if you want to do it the hard way, you do it like by importing your state and then kind of writing the Terraform file from that. But with Terraformer, it kind of just does that sort of like grunt work for you, and it's quite nice. Yes, Jarland.
Yeah, hello. So I have a question about the data processing pipelines. DKIST are using Airflow to manage the data processing pipelines, and I think Punch Mission will be using Prefect. Are you using some kind of tool for managing those for the data processing pipelines, or did you roll your own, or what was the solution there?
So ours is a sort of kind of our own solution with utilizing kind of the event-based nature with like AWS Lambda functions, which are kind of these like cloud processing functions. So again, it's all like event-based. So the pipeline gets started off when things are like put into or pushed to the cloud, and then it also kind of like pulls things in like an event-based manner, like from the cloud as well. But the beauty with like our pipeline though is that like we're sort of like creating it like piece by piece. So even if you don't utilize the entire thing, you can still utilize like the containers, you can still utilize the packages and into your own solution. And like, especially when we finish up kind of refactoring the sorting function into a container, like that could even be put on Kubernetes if you want. There's like we're trying to make it sort of extendable and not like like, okay, you have to have all our pieces for everything to work nicely. We're trying to like our sort of idea is to kind of build each thing like nice enough so that you can utilize it like by itself in whatever sort of format that you'd like.
Okay, thank you.
Anybody else before we wrap up the meeting? All right, well then if not, thank you all for joining, and thank you both for presenting so much. And we will see you back here in 2 weeks. If anybody didn't see it in the chat, if you're wanting the recording of this session, it will be available on our YouTube channel. And I've got the link here in chat. I will make sure not to remove it. Thank you.
Thank you.
Thanks.